Hello again. In this question, we are given that there's a rope, right? And at the bottom of this rope, you have a mass hanging. So that mass is capital M, right? And the mass itself has some mass per unit length. So let's call that mu. And now you have one wave generated at the top and one wave generated at the bottom. They both move in the opposite direction. Right, so this top point is given to be O, this point is O and this point is A. The wave which originates at O, the time taken by that wave is given to be TOA and the time taken by this wave is TAO, right. So the first option says that TAO is equal to TOA. So let's think about this. You know that speed of the wave is given by root of T by mu, right. So now understand that since this rope has some mass, the tension will vary. It will increase continuously as you go up. I'm sure you understand this. If we look at this particular cross section, if we cut the rope here, you see this entire mass needs to be balanced by tension. Whereas if you cut it here, only this amount of mass is to be balanced, right? So the tension will keep increasing. But to answer this question, you don't even have to solve the equation. All you have to see is that speed at any point is fixed. So speed at this point will be the same for this wave as well as this wave. Similarly, speed will be same at this point for both the waves. So what you can understand is that both of them are going to cross all these points and their speeds are going to be same at all these points. Therefore, they will take the same time. It's just that the order in which they reach those points is opposite, but their speeds at all these points will be same. And since the speeds are the same at all these points, the time taken will be the same, right? So that was the first option. The second option is that velocity of the two pulses are the same at the midpoint of the rope. So of course, we just argued that at any given point, the velocities are the same because the tension will be same at that point and mu depends on the rope. Right. Third option is that the wavelength of pulse 1 becomes longer when it reaches point A. So A is the point which is at the bottom. So the pulse which starts from here, you can see as it goes from O to A, tension is decreasing, so V will come down, right. You know the wave equation is speed is equal to, lambda into frequency, right. Now, as the wave moves, the frequency never changes, right. Since the frequency never changes, as the velocity goes down, wavelength will go down. So here we are told that the pulse will have a longer wavelength, which is clearly wrong because if the speed is decreasing, wavelength will come down, right. So option C is not correct. The last option is that the velocity of any pulse along the rope is independent of its frequency and wavelength, which is true. You know velocity only depends on T and mu and not on the frequency or the wavelength, right. Speed of a wave always depends only on the medium.